Okay, today we're going to talk about one-step equations, so solving and finding the solution to those. First of all, the golden rule of algebra. What we do to one side of an equation, we must do to the other side. That's always the golden rule. It's like a balancing scale. We want to make sure that we do the even things on both sides. So if you do one thing to one side, you got to do it to the other. All right, so to find the solution, you must isolate the variable. So what isolate means, it means get it all by itself on one side. So we'll talk about that in a second, you'll see what I mean. So we want to isolate the variable. So this means get the variable alone on one side of the equal sign. All right, so inverse operations. Inverse means opposite. The opposite of addition is subtraction. The opposite of subtraction is addition. And the opposite of multiplication is division, and the opposite of division is multiplication. So inverse operation, that's how we get rid of something and isolate the variable. So if we look at this, we want to know how do you find the solution. So we have a variable x plus 12 equals 45. So first you got to ask yourself, what is the inverse operation of addition? So just like we said back here, the inverse operation or the opposite of addition is subtraction. So what we're going to do is we're going to subtract, and since it says 12, that means we're going to take 12 away. And just like we talked about on our golden rule, what we do to one side, we have to do the other. Because if I take 12 away from here, I'm not going to be balanced out, so I need to take 12 away from this side. I'm going to put this little line underneath it just to show that I'm done with that part. Alright, now I have positive 12 minus 12, so if I do positive 12 minus 12, I'm going to get 0. Alright, so I can go x plus 0 over here, and that equals, and then 5 minus 2 is 3, 4 minus 1 is 3. So now I have x plus 0 equals 33. Now I don't have to write x plus 0 because my identity property of addition says if I add anything to 0, I'm going to get the same thing, so I can just write x. So now I have x equals 33. So now x is alone, so that's what I think my answer is. But the great thing about solving equations, we can always plug it back in to see if it's right. So wherever I see in my original problem, my x plus 12 equals 45, wherever I see an x, since I said it was 33, I'm going to plug a 33 in. So I'm going to substitute 33 in right here. I'm going to rewrite out everything I had. So the only thing I changed here was the x. So I said x was 33, I did the plus, I did the 12, equals 45. So now I check it. So 3 plus 2 is 5, 3 plus 1 is 4, and 45 does equal 45. So that means I know I got that right. Okay, so that's how we solve that. Alright, so now we got another one, but now they put the addition, or the variable on the other side, and they put the equals on this side. So now I can, if I wanted to, I can rewrite it. I can write x plus 19 equals 192. That makes it the same way. But I'm going to keep it the same, just how it was, just so we can get an example of that. So just like we did before, the opposite of addition is subtraction. So we're going to minus 19 from both sides. Okay. Now again, positive 19 minus 19 is 0. So again, if I want to, I can write x plus 0. So I can't take 9 from 2, so I got to borrow. So that becomes an 8. Now I have a 12. So 12 minus 9 is 3. 8 minus 1 is 7. And then bring down my 1. So now I have 173 equals x plus 0. But again, identity property of addition says anything plus 0 equals itself. So now I have 173 equals x. Now, again, can always do our check step. So I got the 192 equals x plus 19. And since I said x was 173, I'm going to copy down everything I don't use. And where I had the x, I'm going to put the 173. Okay, now we check. So 173 plus 19, 9 plus 3 is 12. We're going to carry the 1. So it's going to be 1 plus 7 is 8. Plus 1 is 9. And then we're going to bring our 1 down. So again, 192 does in fact equal 192. So we know we got that right. Alright, so like we said before, these are like a balancing scale. So you have your x plus 12 equals, and so you have this red triangle, and so that equals, whenever you see the red triangle, it means it's an equal sign, or any type of triangle on these scale, equals 45. So you got to ask yourself again, x is our variable that we want to isolate. So how do I isolate that? I got to do the inverse of what's next to the x. So the inverse of plus 12, or the opposite of plus 12, is minus 12. So we're going to do that. So we took 12 away from over here. So now I'm not balanced. So just like our golden rule of algebra, we said we got to do the same thing to both sides. So back to what it was. So we're going to do the same thing to both sides and take 12 away. So minus 12, minus 12. So now I have x just over here equals 5 minus 2 is 3, 4 minus 1 is 3. Alright, so now we had x equals 33. So that's what we said. We're going to take 12 away from both sides. And we're going to get x plus 0 equals 33. Again, identity property of addition says I can add anything to x, or anything to 0, and I will get the same thing. So we can just write x equals 33. And so that's how we solve that. So now back to our golden rule of algebra. Always, 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 what you do to one side, you must do to the other. So do to one side what you do to the other. Always. Alright, if I want to solve this equation, we're going to solve it. So it says x plus 15 equals 55. Opposite of plus is minus. So minus 15 to both sides. Minus 15. And so take 15 away from both of those. So x equals, that's going to be 40. Okay? Can always do our check step. Same thing over here. Minus 11. Minus 11. This is going to end up being a 62. This is going to be just an x. So x equals 62. Alright, golden rule of algebra. Always do to one side what you do to the other. Alright, so let's do some practice. So go ahead and pause the video and try it yourself, and when you're ready you can go ahead and come back. Alright, welcome back. So we're going to solve these. So quick, I'll just go through it real quick. So minus 40, minus 40, so this is going to be x equals 60. Plug it back in, make sure it works. So now I get 100 equals 100, so I know I got that right. Okay. Next one, we're going to go minus 13, minus 13. So I'm going to get 17 equals x. We want to plug it back in, make sure it works. 17 plus 13 is 30. So we know we got that right, since 30 equals 30. And then the last one over here, we'll use pink. We'll go minus 9, minus 9. So 56 minus 9 is going to give me 47. And we're just going to have x left over here because we have the x plus 0, but we don't have to write the plus 0 because that's just the identity property. So plug it back in, make sure it works. 47 plus 9, you can check that in your calculator. So 56 does equal 56, so you know 47 is correct. Alright, so I hope you did good on that. Alright, so to sum it all up, golden rule of algebra, always do to one side what you do to the other. How do you solve a one-step equation? We do the inverse operation in order to isolate the variable. And it says, why do we use letters instead of numbers in mathematics? Because it's just a variable, and sometimes we don't know what that number is, and so we use a variable for an unknown number. All right. So we practiced with all addition. So now we're going to do some ones with subtraction, ones with division, and ones with multiplication. So go ahead and pause this again and come back when you're ready, and we'll go ahead and check them and make sure we did it good. Alright, welcome back. So this one, x minus 22 equals 36. Here's our variable, so we want to isolate it. So we isolate that by getting rid of what's next to it. So the opposite of minus 22 is plus 22. So golden rule of algebra says do to one side what you do to the other. So you have just an x over here. 6 plus 2 is 8. 3 plus 2 is 5. So I'm saying x equals 58. So plug that back in. Make sure it works. So 2 minus 8 is 6. 2 minus 5 is 3. Or I'm sorry, 5 minus 2 is 3. So 36 does equal 36. So we know we got that right. Right. Over here. You should know that when two things are right next to each other, that it means multiplication. So the opposite of multiplication is division. So we're going to divide both sides by 7. So when we do 56 divided by 7, it's going to give me 8. So now I have 8 equals x. So now again, like always, we're going to plug our stuff back in. Now, when we do this, if I just write it like this and I just plug that 8 in for the x, this looks like 56 equals 78. And that wouldn't be right. But that doesn't mean just put the 8 in right here. This means multiply. So we need to make sure we multiply it. So we put parentheses around the 8 to make sure that we represent multiply. So now it says 56 equals 7 times 8. And so 7 times 8 is 56. So we know we got that one correct. All right, and then the last one over here. So 17 equals x over 2. Now remember, a fraction bar is just a fancy way for using division. So this really just means x divided by 2. So the opposite of divided by 2 is multiplication. So we're going to multiply both sides by 2. So 2 times 17 is 34. So I'm saying 34 equals x. Plug it back in, make sure it works. 34 divided by 2 is 17. So you know we got that correct. All right. Alright, now we have a couple with integers, so I'm going to go ahead and go through these. You can pause it to check and make sure that you know how to do it. We're going to go ahead and just add -3 to both sides. Okay, these are different signs, so different signs means we subtract them and keep the sign of the bigger one. So x equals, and it's going to be 7 minus 3 is 4, and since I had more positives with the 7, I'm going to keep it as a positive. So this is going to be x equals 4. Alright, over here, opposite of -12 is a positive 12, so I'm going to add 12 to both sides. So now I have x equals different signs, so we're going to go 12 minus 4 is 8, and we had more positives, so x equals 8. Okay, we're going to go minus a -5, minus a -5, so that's going to give me, we can use stay change opposite here because we don't like to subtract by negatives. So -9, change minus to plus, and the opposite of -5 is 5. So now -5 or -9 plus 5 off different signs, so we subtract. So 9 minus 5 is 4. We had more negatives because of the 9, so -4 equals x. Right, over here, -2 times x, so we're going to divide by -2. Divided by -2, -14 divided by -2, we have two negative signs, so when we have an even number of negative signs, that makes it positive, so it makes that 7, so this is going to be x equals 7. Right, x divided by -3, so we're going to multiply by -3, so now x equals, since I have an odd number of negative signs, it's going to be negative, so x equals -6. 2 times -3 is -6. And then our last one, we're going to go plus -12 plus -12. So x is going to equal 3. Right? Moving along, we can also do stuff with decimals. So it's the same exact process. So here you're going to go minus 1.2, minus 1.2. So x is going to equal 2.3, minus 7.6, minus 7.6. So this is going to be x equals -10.8, plus 7.9, plus 7.9. X is going to equal 20. And then minus 3.1, minus 3.1. So x is going to equal -12.1. Right, so that's how we do it with decimals, same exact process. And then finally, we can also do it with fractions. So we're going to go minus 2/3, minus 2/3. So x is going to equal 1 in this case, minus 3 1/4, minus 3 1/4. So x is going to equal 2 2/4. Whoops. Sorry. X is going to equal 2 2/4, which we can simplify to 2 1/2. We're going to add 3 1/4 over here. Now you should know your fraction rules to where you need to have a common denominator here. So the common denominator is going to make this a 4. It's going to make that a 2. So this is going to end up being 11 3/4. And then finally, we can go minus 3 1/3 here. Minus 3 1/3. Again, we have to have a common denominator, so it's going to end up making this 2/6. So when we subtract these, I'm going to end up with negative 5 7/6, which is simplified to negative 6 1/6. Alright, so that is solving equations, one-step equations. I hope that helped you and you understand it. If not, feel free to come in and ask me some questions.